Hello class, we are now starting a new unit called Filling and Wrapping, three-dimensional measurement. Just to transition into what we are talking about, let's just cover some basics here first. We have been working with two-dimensional objects so far, things like squares and rectangles and triangles. Now we're going to be working with three-dimensional objects. Basically, instead of it being flat, it's now almost it's popped up off the ground, I guess, for description purposes, lacks of a better term. But anyways, here's some examples of a three-dimensional object. Basketball and baseballs are spherical three-dimensional objects instead of a circle. And then the boxes that hold it for like consumers and stuff when you sell it, those are examples of three-dimensional objects instead of being like a square or something. So these are just different parts of the unit that we'll be covering so that you can understand where we are heading. As you very well know, in purchasing a lot of different things in stores and stuff, there is other things besides just boxes that fill or that are located in the store that allow you to consume or to take home certain things you want to purchase. So, like for example, Lay's wavy chips. In the corner here, that's a three-dimensional object that holds chips. Instead of it being flat, and it has three dimensions to it. So you can hold things and put things in it. That's the point of a three-dimensional object, or that's what the characteristic of a three-dimensional object. You can put things in it. So here, obviously, Tide, that's a three-dimensional object. These are different shapes that you could use. And here's a can is very unique in the respect that, if it was a one or a two-dimensional object instead of a three-dimensional object, two-dimensional object would be just a circle on top, whereas a three-dimensional object, it can three dimensions allows you to hold things in it, so it's like a can, three-dimensional. So anyways, there's just different elements that you would see, or different examples you would see at a store or something like that. So in this unit, we will be looking at two different measures involved in three-dimension shapes. You will explore how much material it takes to fill a shape and how much material it needs to wrap a shape. So filling regarding volume or what's inside, and then the wrap part is what's, if we wanted to find the amount of volume it covers out the outside of it, the surface area. So we're first going to be talking about cubes. So just so you can see where we're heading for this particular problem, problem 1.1, we're going to be talking about cubes and rectangles, 1.1 and 1.2. So Mountain Dew being a favorite in soda world, it's kind of nice to kind of see where we're heading in cubic meters and stuff like that. So not cubic meters, but just cubes in general. So those are different examples of what a cube looks like. For this problem, here are our goals. Visualize a net as a representation of a surface area of a cube and connect the area of the net to the surface area of the cube. So our hope and our goal is that you can understand that a two-dimensional object can be cut or folded or made into a design that allows you to make a three-dimensional object. So as you can see here, here's a two-dimensional object that here's the design that's allotted here. Allows you to possibly make into a three-dimensional object such as a cube. If we look here at the transition, a net, the net is something, a very important term. A net is a two-dimensional pattern that can be folded to form a three-dimensional figure. So here's this transition of here's the net part of it. Here's the net. And then here then transitions to the cube. Now, just a point of thought that I want you to think about is that there are many different designs that a net could be in order to make this cube. And if you can think about those different designs, that's something we're going to be covering in class that you'll have to find in class tomorrow. So feel free to start thinking about that. But here's some questions I want you to answer. What is the difference between a three-dimensional object and a two-dimensional object? What does a cube look like? And what do you think a face of a cube looks like? Describe what a net of a cube is. So we kind of touched on some of those questions, but I think this third one here, you may have to kind of think about what a face would be of a particular object for you to answer that question. So take the time, go ahead, answer those questions, and have it ready by the time class starts. Thank you. Thanks for watching. Bye-bye.